Hello, today we're going to make the front loader which I used in my previous video to load a full Euro cylinder. I'll be using a program called SketchUp Make 2017, and this is a 3D modeling program which is distributed by Google and it's free to use. I know that there are better programs out there which can be used for 3D modeling, like 123D by AutoCAD or Autodesk, sorry. But I know how to use this program, and this is what I'm going to show. So we start by creating a polygon with 12 sides. So you can use Control plus and Control minus to control the number of sides of the polygon. And the radius of the polygon will be 6.25 millimeters, because we know that the diameter of a regular plug is about 12.5 millimeters. So the radius is half of that. Let's zoom in. Okay, so this is going to be the base of our front loader. And why is this base good for us? This is because let me show you. I'll no, not this. I'll do explode curve. Now we can select each of the sides. So each side is 3.23 millimeters, which is exactly the size that we want to make our holes, because the holes of the pins are going to be around 3 millimeters, and this side is perfect to make the holes. Okay, so let's go back and extend our shape about, let's say, 50 millimeters. So this is going to be the base of our plug follower, and just for convenience I want to align at least one side with one of the axes. So let's spin it around, no, not like that. So I need to select everything and then spin it around the center 15 degrees. Okay, so now I have this side aligned with the axis. Okay, so let's continue with making the hole for the knife tool to drop the pins. Okay, so for convenience, let's explode this curve, and now mark 2 lines here on the side. Now we want to create a centered hole, and the best way to do it is to go 1.1 millimeter from each side and 8 millimeters from this side. So I found that this is the perfect size for the hole. So the length here is 8 millimeters, and here about 1 millimeter. This is the perfect size for this hole, but we won't cut the hole through yet, and instead let's we'll draw two vertical lines like this. This will create guides for when we want to create the holes of the pins themselves. Now we need to make a little slot on the side for the for the for the pinning shoe when we turn the plug follower and let the pinning shoe hold the pins when they're inside the core. So let's do it next. Okay, so the pinning shoe hole will be perpendicular and the size of the hole which fits the the HUK pinning shoe is going to be 2.7 millimeters. So let's take a guide of 2.7 millimeters and the distance from the side should be 1 millimeter. Okay, so for this we can simply cut the hole directly. So now we have the hole for the pinning shoe when all the pins are loaded and we want to turn the core. And basically we have, let's delete all the guides. So we should now save this as our basic front loader. This is generic and will fit all the locks that you want to create. But starting from the next step, you will actually need to measure the distances between the pinholes and create something which is specific for your lock. So this is not going to be a generic front loader, but a specific front loader. So I already measured mine, and I know that the distance between each two pins is 1.3 millimeters, and the distance between the final pin and the lock edge where I need to put the stop is another 1.9 millimeters. Okay, so we'll do the holes in the next section. Okay, I forgot to save, so I will save this as front loader base. And I'll put this on my Thingiverse profile so anyone can download it. And you can just start off from this model already. The next thing we'll do is to create the holes. So let's create a guide through the center where we want to put the holes. And let's say we want to start the holes, and let's say we want to start the holes about, let's say 1 millimeter from the top. Okay, so each hole is going to be 3 millimeters in diameter, and the difference, the gap between the holes is going to be 1.3 millimeters. So, and I'm bad at math, so let's bring in the calculator. Okay, so we took 1 millimeter from the top to this line, and therefore we want another 1.5 millimeters. So we have the 1 millimeter and another 1.5. So that's 2.5 millimeters. to 0.5 for the center of the circle. Okay, so to the end of the circle we have another 1.5, and then the 1.3 millimeter gap, and then another 1.5 to the center of the circle. So wait, I forgot how much. 6.8. So now I need 6.8. 6.8. So this is the center of the next circle. Okay, so let's do the rest. So I need more. And 6.8 plus 1.3. And now next one is 0.1. Come on. Okay, 11.1. 15.4, and we have already 1, 2, 3, 4. So 9.7, and then I know that after the final hole, so I need another half circle, so plus 1.5 is the half circle, and plus 1.9, which is the distance between the circle, the pinhole, and the stopper, which I need for the front loader. So 23.1. Okay, let's just mark this final line as the line for our stopper, and create the holes for the pins. So each hole is 1.5 millimeters. 5 5 and half. So I'm doing this for a 5-pin core, but of course the steps are the same if you're doing a 6 or 7 pin core. So now that we have all the holes marked out, we just need to cut out the proper holes, and this is what we're going to do next in the next section. So we know that the depth of the cutout here is going to be 8 millimeters, but we want to make the holes just 2 millimeters more into the loader, so that the pins won't fall out when you put them inside the holes. So this is not necessary, but I think it's a nice feature which holds the pins together, holds the pins properly inside the loader. So this is 8. First of all, I'll push everything in this slot 8 millimeters inside. And now we can push the holes of the circle. Let's push them 2 more millimeters. So basically we're creating a cavity which is slightly more into the pushed into the loader than the actual slot. Two. I'm sure there's a faster way to do it, but this is how I do it. Okay, so all our slots ready, and now we need to think about the stopper. So let's make the stopper, let's say 2.5 millimeters. I think it doesn't really matter, it just needs to be like a bulge that will uh, won't allow the loader to go fully into the lock itself, into the lock body. And let's make it, say, 2.5 millimeters. And then we can push this. Oh, wait, I need to push that in. Wait, how much is this? No, this is not good. I need this to be 2.5. It doesn't have to be exact. So basically this is the front loader with the stop, and just I'm going to print it standing up. So a part which extrudes like that is pretty hard to print because the printer can't actually print something which is in the air, and we really don't want to print it with supports. So what we can do is basically help the printer by making a sort of stairway for it to build up until it reaches the full length of this ledge. So let's do it by selecting this and moving it. Oh, no. And the same with him. Okay, so this addition only helps the 3D printer to build up on this ledge and until it can print the 2.5 millimeters of ledge here. And now we don't need to print it with supports. So basically that's it. The front loader is ready, and it can be printed. So this is front loader, let's say 1 point. So I already have is the 1.3, 1.9 because 1.3 gap between the holes and 1.9 gap until the stopper. So I won't save it. Okay, thank you for watching, and I hope you can make something like this, and it will help you to load pins into your full Euro cylinders. Goodbye.